This is a lesson on writing and naming acids and bases. Acids. There are two main types of acids that you can name. First of all, an acid is a substance that usually begins with an H. They produce, by one definition, H plus ions in solution when they ionize, when they fall apart. If it reacts with water, and there's usually water in solution, you produce something called the hydronium ion. This is what is really present in water, the hydronium ion. Sometimes people will shortcut it to H plus. In real life, it's this. This is radioactive, this is not. So you get a lot of hydronium ions if you have an acid. So most acids, not all, but most acids start with an H. There are four common strong acids, or four common acids that we will use in our chemistry laboratories. HCl, HNO3, H2SO4, HC2H3O2, or as the book likes to show it, CH3COOH. COOH is an ending that you see for organic acids. HCl is hydrochloric acid. HNO3 is nitric acid. H2SO4 is sulfuric acid. HC2H3O2 or CH3COOH are both acetic acid. Hydrochloric acid is stomach acid. Nitric acid is found in smog. It's the brownish yellow stuff that you see in the air above Los Angeles. Sulfuric acid is battery acid, and you also see it in acid rain in the eastern New England states because they burn coal with large amount of sulfur in it. And acetic acid is vinegar, another form of vinegar. As you notice, there's two general rules. The hydrochloric acid has hydro in it, and none of the other ones do. Nitric acid, sulfuric acid, and acetic acid all have H in front of a polyatomic ion. Hydrochloric acid has an H in front of a monatomic ion. So if it's two elements only, if it's H something, then it's hydroic acid. If it's HF, it would be hydrofluoric acid. H2S, hydrosulfuric acid. H2SE, hydroselenic acid. So these are the acids where you have two elements only, you do not have a polyatomic ion. The other basic acid is if you have a polyatomic ion. In this case, you have H something O. you have a number down there or not. These are the ic acids. And we're only going to do those that end with 8. So H3PO4, PO4 is phosphate, so that would be phosphoric acid. Up here, SO4 is sulfate, so it's sulfuric acid. Acetate, acetic acid. So if you have any polyatomic ion that ends with 8, it's an ic acid. There are other acids. We're not going to go into those. If it's a chlorite or hyperchlorite, any of those weird polyatomic ions that we did. So if I give you a test question and it has an oxygen in it, assume that polyatomic ion is something 8, and therefore you name it ic acid. So if it's SeO3, we'll assume that's selenate, so that'd be selenic acid. That's why the homework is bouncing around. Bases. Bases we've already covered because bases are things that end with OH or hydroxides. They make OH minus ions. So you just follow the ionic rules. NaOH is one of the most common acids. It's Li, found in Drano. This would be sodium hydroxide. So if it ends with hydroxide, if it ends with OH, it's a base. FeOH3, iron 3 hydroxide. It's a base, very weak base, but it is a base. Again, chemistry is made up of exceptions. The lone exception is NH3, that is ammonia. Ammonia in water, what it'll do is it'll take one of the H's from the water and it'll make NH4+. Well, what's left if you take an H from an H2O? You're left with an OH minus. So that's where the OH minus comes from. It doesn't come from the NH3. It comes from the NH3 taking one of these H's from the water and leaving an OH in solution. All you really need to know is NH3 or ammonia is a base, along with anything that ends with hydroxide. That ends this lesson on acids and bases.